First, you need to say that why we go for the analysis. Why analysis? Why we need to analyze the algorithms. So we have already seen that for some problems we may have more than one algorithms. Okay, and you have some different ideas by your experience. Using your experience, you may have some different design techniques for the algorithm, and you may come to know that okay, this is the algorithm which can behave efficiently as compared with the existing one. So how would you know that your algorithms nowadays? See, you have the many challenging problems in the computer science, and every day people are going to improve, giving the improvement on the existing solutions. So how we would come to know that our solutions or our formalism is an improvement of the existing one? For that, actually, you need to go for the analysis. And whenever you go for the analysis, this means you are determining the computational behavior of your algorithms. So sometimes I may say that okay, what is your analysis, or what is the your analysis, or I may say that what is the computational time your algorithm requires, or I may say that what is the computational behavior of your algorithm, or sometimes simply say that can you determine the time of your algorithm. So people will ask in different way. So once you go for the analysis, actually, then you come to know the behavior of your algorithms, and you come to know that your algorithm takes some input, and you will come to know then this is the input that is in favor of my algorithm. Means if you supply that input, then your algorithm will run very quickly and it will take minimum amount of time. And for such kind of some different input, your algorithm will be worst. It means your algorithm may take maximum amount of time. So when we go for the analysis, generally we go for the analysis in three different cases. One is best case, then we will go for the, we can say that, average case, and we can go for the worst case. Okay, so there are, in your algorithm you can present the analysis in three different cases. One is the best case. This is the best case of your algorithm. This means you are going to determine that okay, this is the minimum amount of resources your algorithm will require. So best case says that what is the minimum amount of resource your algorithm will take if the input favors your algorithm. Means if you supply some input that is according to your algorithm and your algorithm will favor such kind of input, then what is the minimum requirement of the resources? So best case will denote the minimum resource requirement of your algorithm that will favor it. Okay, that input is going to favor in your algorithm. Once you go for the worst case, you are going to determining the worst case behavior of your algorithm. This means what are the resources needed to execute your algorithm in worst case, and this worst case come for the worst case input, and you will tell that okay, this is the input for which your algorithm will behave worstly, and this is the input for which your algorithm will take minimum amount of time. The worst case will denote the upper, you are claiming for the upper cases. So you have the, okay, so you have the algorithm and you are going to supply some input, and here is your the time. Okay, so when you say that the best case, then you can say that if for some the best case of your algorithm may be like this, means your algorithm, if everything is in favor of your algorithm, then your algorithm may require this time. If you go for the worst case, then you will say that okay, my algorithm will take this much time in worst case. And whenever you say that this is the maximum time your algorithm requires, this means whatever with the input you can supply, your algorithm will not run more than this time. In worst, if you have some worst case input, your algorithm may go up to this only, but it will not go beyond this. So whenever you present the worst case behavior, then you are setting the upper bound of your algorithm, and you are telling that this is the input that leads to your algorithm for going for the execution in the worst case. So worst case comes when your input is not going to favor your algorithm. Once you analyze the algorithm in worst case, irrespective of the input, you are claiming here that this is the worst case behavior. And whatever input size is there, your algorithm will not run more than this time. Whatever input you can give, your algorithm will not run less than this time if you are giving the analysis for the best case. Now average case is what? You should don't say that worst case time and best case time. If you go for the average of the worst case and best case, then this is the average. No, this is not the average time. Usually computation of the average time of any algorithm is a very difficult task. It's not an easy job. And for computation of this average case time of your algorithm requires some concept of the probability theory, and we will assume that your input is equally likely, okay, and we have the probability for the termination equally likely, and it depends on the problems. Once a particular problem you are going to solve, then you come to know that how you are going to analyze the average case. But simply the meaning of the average case is that, so you can say that, okay, I'm running my algorithm for some time, say n1 time is this, and your algorithm is going to behave like this for the different input, for the different possible situations input, your algorithm may take this time. Okay, like you can take the example of the linear search. If you have the linear search like this, so how you are going to perform the linear search? You need to come, if you are suppose given an element to search, then you have to start from the beginning, and you can compare this element with this element. And if you are going to search the item, and this is the first item in your list, then you just make only one comparison and stop. Okay, yes, item is found at location 1. So if item is found at location 1, how many comparisons you require? One comparisons. If item is found at location 2, how many comparisons you know? 1 and 2. So you need 2 comparisons. If your item is found in the location 3, then you need 3 comparisons. If it is found in the location 4, then you need 4 comparisons, and so on. If your item is at the last, you need how much comparisons? You need to perform n comparison in the linear search. And in worst case, your item may be at the last, or your item may not be in the list. If your item is not in the list, then also you need to make n comparisons for deciding that your element is not in the list. So see, if your item present at the first location, then you have the time this. If item present in the second location, then you need this much number of comparison. Third location, this much number of comparison. In the fourth location, you require this much number of comparisons. And the last or element may not be in the list, then you require n number of comparisons. Now for computation of the average case analysis, you need to find the summation and then divide by n. And this is the average case. So here, this is the average case analysis of the linear search you are going to make. And this is the on average, this is the number of comparison operations you require for the case of the linear search. And here what we believe that, you are searching the item, say you are searching the value k, and k can be at this position, k can be in the second position, k can be in the third position, or k can be in the nth position, and k may not be in the list also. So being the ith element of this element k has an equally likely probability. This means there is an equally likely probability that item can be found at the first location, or item can be found in the second location, item can be found in the third, item can be found in the fourth, item can be found in the fifth or another location. So here we are, you have to use the concept of the probability theory to believe that it is has the equally likely probability of being the ith element. And then this is the average case analysis. So see that determining the average case analysis is not an easy job as compared with the best case and worst case analysis. So average case analysis is always difficult, and very few cases we will go for the average case analysis. However, most of the time we restrict our study with the best case and worst case. So generally we present the analysis in three different cases: best, average case and worst case. Okay. So now what are the major resources of your algorithm will take? Whenever you say that analysis of algorithm, this means you need to, our major resources is what? Our major resources is computation time, means CPU time, and memory requirement. When you are going to present the analysis of your algorithm, you need to determine the computation time needed by your algorithm for the termination, and also you need to determine what is the amount of storage you need for the completions. So these are the two major resources of your algorithm. There are other resources your algorithm will take. So depends on the situation when you are writing the algorithm for those purpose. Like if your algorithm is going to access the internet, then you need also to count how many times your algorithm is going to access the internet. If your algorithm is requiring to access the secondary storage, then also you need to know that how many times your algorithm is going to access the secondary storage, as accessing the secondary storage takes much time as compared with the accessing the primary memory. So these are the parameters you need to know also in that cases if your algorithm requires to access secondary storage or if your algorithm requires to access the internet, because every time you go for the accessing the internet depends on the load of the internet. It may run fast or it may give the value respond the quickly or it may respond late. Also you may count the number of CPU register you need to modify, or you may need to know that how many CPU registers or what are the files you need to open for the completion of the algorithms. But major resources of our algorithm is, once somebody says that okay, what is the analysis of your algorithm, this means you need to generally present computation time and memory requirement. Okay, so most of the time cases we say that storage requirement of the algorithm is same, but time may be different. So when you say, somebody says that okay, present the analysis of algorithm, generally we present the computation time of the algorithm. And when someone is interested for both the cases, then he may say that what is the computation time and what is the storage requirement of your algorithms. Then you can do both. So major resource of your algorithm is computation time, CPU time, and the memory requirement, and accordingly we will have the time complexity of your algorithm, which is known as the time complexity, we say, or we will have the storage requirement. You can determine the memory, or you can say that storage requirement. So time and memory. Okay. So when you say that time requirement or time complexity of your algorithm, this means the amount of CPU time. This is the amount of CPU time we are interested. needed to complete. So amount of CPU time we need to complete the algorithm, that is the time requirement, or you can say the time complexity or computation time, you can say. So generally time complexity means execution time. We have the execution time plus compilation time. So you know that once you are writing the programs and you need to compile the program, then it also takes some time. And once your compilation is done, then you are going to execute the programs, and then whatever the execution time. So this the time requirement of algorithm is actually, if you go for the time complexity, then actually you need to determine the execution time plus compilation time. But believe that we are going to believe that compilation time is needed at once, and once you compile and once you whenever we have the compiled program, you can run several times. Compilation is needed at the during the development of program, and one time is needed. And with this intuition, we are worried about the execution time. So once we say what is the time complexity of your algorithms, or what is the time requirement of your algorithm, or what is the computational behavior of algorithm, actually we are interested for the CPU time of your algorithm. So amount of CPU time we need for completion of the algorithm. This is the time complexity. Storage requirement or storage complexity, space, which is the space complexity, you can say space complexity. So space complexity is the maximum amount of storage. Okay, maximum storage requirement of memory needed to complete. So this you can determine. This is the with the help of the storage requirement. If you are interested for determining the what is the amount of memory you need for completion of the algorithm. So see, you can have the situation like this. Okay, at the beginning you may require, if you this is the memory requirement, and here, okay, you may have execution, you are going to execute, and sometimes you may require this much of amount of memory. After sometimes you may require this much of memory. After sometimes you may require this amount of memory. Also sometimes you may have this kind of memory, or sometimes you can go for this kind of memory. And here, then you are going to complete. Here you are going to complete. So see, if you want to run your algorithm, then you need to know that sometimes you require this memory, and sometimes you may require this amount of memory. But what is the maximum amount of memory you need for completion? If you don't have this much amount, you cannot run this part. If you are not able to run this part, your algorithm will not complete. So once you are going to say the space complexity of algorithm, this is the maximum amount of memory, maximum memory requirement of your algorithm. This is the amount of memory you need to complete your algorithm. So this is the amount. So this, for execution of your algorithm, this is the amount of memory you need, and this is the storage requirement. So whenever you are going for the storage requirement, then actually you need to determine what is the maximum amount of memory we need for the completion. The completion is important, because if you can execute up to some part, but if you don't have enough memory, and your system requires this much amount of memory, then you can't complete. So once your algorithm is going to complete, then actually maximum amount of memory you needed is this. So this is the space complexity of your algorithm. So time complexity and space complexity. These are the two important factors. So one is time and other one is the space. whenever we go for the time complexity of our algorithms, then actually what we are going to do, we will count the operations in your algorithm. So actually we are not interested for the time. Actually, whenever you may see think strange that we are doing the time complexity and we are not going to determine the time in millisecond or microsecond or nanosecond, whatever. We are not worry about the exact time. Okay. We are not interested in the exact time. Exact time is not fruitful actually, because I have already told you that exact time is needed only for your system. If you are running the program and you want to know that you have the two different algorithms and which algorithm runs fast for your system, then you can determine the exact time. However, this time is only for your system. You cannot make a general comment that okay, your algorithm requires this much time or this microsecond time or nanosecond time. No, this is for only for your system. So that's why instead of determining the exact time, once you go for the time complexity, we are going to determine we will count the operations of your algorithm. We are going to count the operation. So we are going to count number of operations. So we need to count the number of operations. So why operations we need? Say you may be for some algorithm we may be required like matrix multiplication. We may require to count number of matrix multiplication operation. Multiplication. Okay. So you may be required to count the number of multiplications. How many multiplications are there? Because you know that in matrix multiplication, the major operation is what? Multiplication, with the intuition that addition takes less time, whereas multiplication takes more time. So what is our intuition? Our intuition is to minimize the number of multiplication. We need to minimize this operation. So for determining the time of your algorithm, actually what we are going to do, we are just counting the operations. In case of the searching and sorting, the major operation is what? Actually, whenever we go for the analysis of the algorithm, we need to think that what is the major operations of your algorithm. Means you need to determine that what are the operations that will affect the time of your system. So what you need to minimize, and your analysis should be based on those operations. Like in case of the searching or sorting, the major operation is element comparisons. So we are worried about the minimization of the number of element comparison. So your analysis will be based on the number of, on behalf of the input. If this is the number of elements, how many number of comparisons we require for the searching, or what are the number of comparisons we need for the case of sorting if you are writing the sorting algorithm. So here the major operation is comparisons. So you need to present your analysis on behalf of the input side. Means if you have the n number of elements, how many comparisons is required if you are for the searching, if you have written for the searching algorithm, or if it is the sorting algorithm, then you need to know that how many comparisons you need for the sorting purpose. Okay. So first, before going to analysis of your algorithm, first you need to know that what you need to minimize, which operations you need to minimize. This is very important. And what are if first you identify that okay, this is the operation we need to minimize, this takes much time, then you also need to know that on which this operation depends. What is the input parameter on which this operation is going to depend. So just need to know the input parameters, what is the input on which your operation depends. So you have to present the analysis on behalf of the input and that operations. So here actually in case of the time complexity, we are not going to say that okay, this is the time we require simply. This is the microsecond or microsecond or nanosecond time. We are not going to say. We just present the number of operations, and number of operations, not all operations, number of major operations on behalf of the input. With respect to the input, this is the number of major operations required. This we will present. Why it is so? Because we know that different system will behave differently. So just present the number of counting, number of operations. Okay, this algorithm requires this much number of operations. Now, if I'm running in my system, and if my system is very fast for that operation, it will run quickly. If somebody is going to run in their system, and if that operation requires much time for running, then that system will be slow for the same algorithm. So here time will be taken on proportion of the number of instructions. So that's what whenever we go for the time complexity, actually we first need to know that what are the major operations in your algorithm and which operation is costly, and we need to minimize, and on behalf of which input we need to minimize this operation, and you have to present the analysis. So presenting the time complexity means you are just presenting the number of operations required by your algorithm. So if you have if you have two algorithms, and if one algorithm takes less number of operations, and other algorithm takes more operations for the same problem, then we generally prefer to take the algorithm that should take the fewer operations. As we know that if you have the less operation, we take less time. If you have more operations, we will take more time. So time complexity means this. Similarly, when you go for the storage analysis, you are not you just require that how many elements you need to store, and what is the storage needed on behalf of your input. So sometimes you need the storage, and elements are there. You may require to store the storage. You need memory for the n elements. If your algorithm is going to use the stack memory, then you have to count the stack memory, runtime stack, if it is going to need it. Then if it is the recursive algorithms, for the recursive algorithm, we know that it needs the runtime stack. So on behalf of the n input parameters, you also need to analyze that this is the stack memory your algorithm is going to need it. So this is the actually, when you have, before going to analysis, you see carefully what is the operation, what are the operations of your algorithm you need to minimize, what are the input parameters on behalf of that these operations are going to change, and going to whether your algorithm takes recursion. If your algorithm is recursiveness, then you will have to count the stack memory also.